Hello, my name is Michael Davis, and this is my video for Exam 2, Part 2. I was given the question regarding the Tumbanga, and I'm going to go over with you my calculations in determining the percent mass. It says calculate the percent copper mass of the sample that was given in the problem. So I'm going to go over this. First, I start with what's given. What's given is our pressure of 843 mmHg. We have the volume of 631.4 milliliters. Now I immediately convert that to liters, just moving the decimal point over to 0.6314 liters. Our temperature, what's given is 50 degrees Celsius. We're going to immediately turn that into Kelvin. We're just going to add 273 plus 50 to get 323 Kelvin. Now, since we're working with the gas that's collected over water, we have to do a side step or an additional calculation, and we're going to look up the pressure. Excuse me. The the chart for vapor pressure over water versus temperature. That chart, because we're working with a gas collected over water. So what's given is the 50 degrees Celsius temperature. And according to our vapor pressure versus water temperature chart, the pressure at 50 degrees Celsius is 92.6 mmHg. Therefore, we're going to subtract that 92.6 from our original pressure of 843 to get 750.4 mmHg. I'm missing my units there. I apologize. And what we're doing is we're calculating our pressure, our atmospheric pressure. So once we get that, we're going to divide that into 760 mmHg because we're converting that into atmospheric pressure. And we're going to get 0.937 atmospheric pressure. From there, we're going to use the ideal gas law. The ideal gas law is PV equals nRT. You can see that I kind of rerouted it to, because what we're looking for moles of NO2. We first have to find the moles of NO2 in order to calculate the moles of copper, then convert that into grams to finally get to our percent mass. But we're almost there. All right. So moles of NO2, we have 0.0193 moles of NO2 after we do our calculation. You can see the 0.937 atmospheres times 0.6314 liters divided by 0.0206 atmosphere liters over moles over Kelvin times our temperature of 373 Kelvin. And I put the chemical equation down here because it's important to note for the next page that the moles of copper, which is what we're looking for. Well, we're looking for the percent mass, but we need the moles of copper first. But we're doing a mole to mole ratio. So the moles of copper and in relation to the moles of NO2. So for every 1 mole of copper, there are 2 moles of NO2. And that's going to come up in our next equation here. So after we have our moles of NO2, we're going to calculate the moles of copper using our moles of NO2, 0.0193, and we're going to do a conversion into copper. So we know, like I just said, that for every 1 mole of copper, there are 2 moles of NO2. So 0.0193 divided by 2 gives us our moles of copper, which is 0.00965 moles of copper. Next, we're going to use our moles of copper to calculate our grams of copper, which is pretty straightforward. Moles to grams is simply just 0.00965 times the molar mass of copper is 63.55 grams, and you're going to get 0.613 grams of copper. Once we have our grams of copper, we are now ready to use our full sample that was given in the problem to calculate the percent mass of the copper within that sample. So we have our grams, and we know that according to the question, the total grams was 6.28 grams. So we're simply going to divide 0.631 grams of copper divided by the full sample, and we're going to multiply that times 100. And I got a percentage of 9.76% of copper in that sample. Again, this is Michael Davis, and this has been my video for part 2 of exam 2. And thank you.